In this, we are going to discuss some of the important parameters which are used to describe the crystal structure. Number of atom per unit cell, coordination number, atomic radius and atomic packing factor. So these are the parameters which are used to describe the crystal structure. So first one is number of atom per unit cell. It is otherwise called as effective number. So number of atom per unit cell is defined as total number of atom present in or shared by a unit cell is called as number of atom per unit cell. In case of simple cubic, it is 1. In case of body-centered cubic structure, it is 2. In case of face-centered cubic structure, it is 4. Next parameter is atomic radius. So atomic radius is defined as half of the distance between any two nearest neighboring atom which are in direct contact with each other. It is usually expressed in terms of cubage A. The next parameter is coordination number. It is defined as the number of nearest neighboring atom to a particular atom. In simple cubic, it is 6. In body-centered cubic structure, it is 8. In face-centered cubic structure, it is 12. The next parameter is atomic packing factor or packing density. Atomic packing factor is defined as the ratio between volume occupied by total number of atom per unit cell to the total volume of the unit cell, small v divided by capital V. Now we are going to discuss one structure, simple cubic structure. So coming to simple cubic structure, it has 8 corner atoms. So first we have to find out the number of atom per unit cell. For that we have to know how many corner atom is present and each corner atom is shared by how many adjacent cell. In simple cubic, each corner atom is shared by 8 adjacent unit cell. So we can write total number of atom per unit cell is equal to 1 by 8 into total number of corner atom. That is 1 by 8 means each corner atom is shared by 8 adjacent unit cell. Then total number of corner atom is 8. So 1 by 8 into 8 is equal to 1. The next one is atomic radius. So atomic radius is defined as half of the distance between any two nearest neighboring atom which are in direct contact with each other. So atomic radius can be expressed in terms of cubage A. Here all the atoms are assumed to be in spherical shape. In simple cubic structure, the corner atom touch each other along the edge. So let us consider one face, that is front face of the simple cubic structure. Here the nearest neighboring distance is given by A is equal to 2R. From this we can write R is equal to A by 2. The next one is coordination number. So coordination number is defined as the number of nearest neighboring atom to a particular atom. So simple cubic unit cell consists of 8 corner atom. Let us consider any one corner atom shared by 8 adjacent unit cell. For this particular atom, there are 4 nearest neighboring atom in its own plane, that is in horizontal plane, and there are 2 more nearest atoms, one directly above it and one directly below it. So all the atoms other than these 6 atoms lie at the greater distance from this particular atom. So the total number of nearest neighboring atom is 6. So coordination number of simple cubic is 6. The next parameter is atomic packing factor. It is defined as ratio between volume occupied by total number of atom per unit cell to the total volume of the unit cell, small v divided by capital V. In simple cubic, the number of atom per unit cell is 1. Then the volume of one atom is 4 by 3 pi r cube. So in that we can replace the radius by A by 2. So volume occupied by total number of atom per unit cell is given by 1 into 4 by 3 pi A by 2 the whole cube. So next we have to find out the total volume of the unit cell. The total volume of the unit cell is given by length into breadth into height. So we can take for cubic system length is equal to breadth is equal to height. So we can write capital V, that is total volume of the unit cell, V is equal to A cube. Now we can substitute in the formula. So atomic packing factor is small v divided by capital V, that is volume occupied by total number of atom per unit cell to the total volume of the unit cell, and we can arrive at 1 into 4 by 3 pi a by 2 the whole cube whole thing divided by a cube is equal to pi by 6. So atomic packing factor is 0.52. Thus we can tell the packing factor or packing density is 52%. Thus we can say that 52% of the volume of the unit cell of simple cubic is occupied by atom, and the remaining 48% of the volume is vacant. So the packing density is 52%. Since the packing density is very low, simple cubic structure has loosely packed structure. So these are the 4 parameters which describes the structure of the crystal. In this we have studied about the simple cubic structure. Thus we can tell 52% is occupied by atom and the remaining 48% is vacant or empty. So simple cubic structure is very loosely packed structure. Only half 50% is occupied by the atom and the remaining 50% empty. So it is having loosely packed structure.